Yeah, in this video, we are going to continue with the West African Examination Council, precisely the West African Senior School Certificate Exam, Chemistry Paper 2. Today, we will be dealing with November 2011. November 2011. But before we continue, my gratitude goes to myschooljist.com for making available the question papers for us. Then, I also want to thank those of you who have taken some time to subscribe to our channel. But for those of you who haven't subscribed to our channel, please love this video, share to other learners, and most importantly, endeavor to subscribe to our channel. Thank you for taking your time to subscribe to our channel. Let's get started. We are starting with November 2011 West African Senior School Certificate Examination, Chemistry Paper 2. Part A, Objective Test. That is 1 hour, and it's 50 questions. 50 marks. Answer all the questions. Each question is followed by 4 options lettered A to D. Find out the correct option for each question and shared in pencil on your answer sheet the answer space which bears the same letter as the option you have chosen. Give only one answer to each question. An example is given below. Which of the following element reacts with water? A. Carbon. B. Iodine. C. Sodium. D. Sulfur. The correct answer is sodium, which is lettered C, and therefore answer space C would be shaded. You see how the answer space C has been shaded? Think carefully before you shade the answer spaces. Erase completely any answer you wish to change. Do all rough work on this question paper. Now answer the following question. We are starting with question number 1. Question number 1. The smallest particle of a substance that can exist on its own and still retain the chemical properties of that substance is A. A radical. B. An ion. C. A molecule. D. A compound. A radical is not a radical. It's not a radical. A radical is a group of elements, or group of atoms. So it's not a radical. What is it? The smallest particle of a substance that can exist on its own, and still retain the chemical properties of that substance. A B, an ion. C, is not a molecule. A molecule is not the smallest substance. It's the smallest particle. D, a compound. No. The appropriate answer for this question is an ion. It's an ion. An ion that can exist on its own and still retain the chemical properties. In this case, we are talking of something like a proton. A proton or an electron. Let me say a proton. Remember that a proton is positively charged. So it's an ion. So the right answer here is ion. It will be shaded. It's going to be shaded. So is an ion. So B is the right answer for this. Question number 2. Consider two atoms represented as X has 8 protons and 16. The nucleon number is 16, or the mass number is 16. And the Y has 8 protons and the nucleon number, or what we call the mass number, is 17. The difference between the atoms is in the A. For purpose of revision, fellow learners, in this type of question, when you look at this question, you will see that this is it's an example of an isotope. These are isotopes. What are isotopes? You see that they have the same they have the same number of protons, but different mass numbers. And the difference in the mass number is as a result of the difference in the number of neutrons. So when you see it, make a review of your knowledge of the proton, the knowledge of isotope or isotopy. Then you go back to your question, your answer column, and see what is there. So the difference between the atoms is in the number of protons. No. The number of neutrons. Yes, from what we have just discussed. What is causing the difference in the number, the difference in the mass number? That is 16 and 17. The difference is in the number of neutrons. So number 2 is B, number of neutrons. Remember that 2 is B. Remember that protons and neutrons will give you the mass number. So question number 3. The number of electrons present in 15. This is an ion of phosphorus. This is an ion of phosphorus. 15 and 31. That is the mass number is 31 and the number of proton 15. So now P3 minus ion is, they say the number of electrons present here. Remember, this is number 3. Remember, the number of protons here, the number of protons here are 15. And we are told that the number of protons equal to the number of electrons. The number of electrons are supposed to be 15. But the number of electrons are supposed to be 15. The number of protons are 15. But the negative sign shows that 3 more electrons have been added to 15. So the number of electrons here will not be, the number of electrons here will no longer be 15. The number of electrons will increase from 15 to 18. From 15 to 18. So the number of electrons in the present in this ion is not 3, is not 15, it's 18. 3 is C, 18. Four. Which of the following ions is monoatomic? Monoatomic ion that is monoatomic. Which of the following ion is monoatomic? A monoatomic is an ion, that is monoatomic ion, that is ion formed from a single atom. Ion formed from a single atom, and the ion has different number of protons and electrons. Ion formed from a single atom. That's monoatomic ion. Ion formed from a single atom, and the ion has different number of protons and electrons. So that ion here, which of the following ion is monoatomic? The ion here is A. It is an ion formed from a single atom, and the ion has different number of protons and electrons. So here we have oxygen and hydrogen. Here we have carbon and nitrogen. Here we have nitrogen and hydrogen. So it is only magnesium here. So this is an ion that is formed from a single atom, and the atom has different number of protons and electrons. So number five, the electron configuration, the correct electron configuration of an element W that has a proton number of 20. Remember, a proton number 20 is equal to 20 is equal to the number of protons, and the number of protons is equal to the number of electrons. So 20 electrons. What we will have for 20 electrons will be let me just write here. 20 electrons here we will have 1s2, 2s2, 2p, 2p6, 3s2. Here we will have 1s2, 2s2, 2p6. That's already 10. This is 12. Then 3p, 3p6, yeah. 4s, 4s. Now this is 2, 4. This is 10. This is 12. This is 18, and it will be 4s2. So it will be 4s2. So altogether 20. So it will end in the s block, in the s orbital. So 4s2. The one that ends in 4s2 is which one? Here we have the correct electron configuration of an element of 20 is, that is 5. 1s2, 2s2, 1s2, 2s2, 3s2. No, the energy level is wrong. We have to finish first with the second energy level. So it is 1s2, 2s2, 2p6, not 3s2. So A is wrong. B, 1s2, 2s2, the one is also wrong. C, 1s2, 2s2, 2p6 is right. Then 3s2 right. 3p8 no. The p orbital has a maximum number of electrons in the p orbital are 6. So C is wrong. Then D, 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. Exactly the one we have just written. So that is our right answer here is D. 5 is D. That's good. 5 is D. That's our right answer. 5 is D. Question number 6. Question number 6. Which of the following sets of elements has the same outermost electron configuration? Outermost configuration. Yeah, that is the number of electrons in the same outermost shell. Okay, we have helium. We have hydrogen is just 1. Helium is just 1 is wrong. 2. We have hydrogen is still 1. It has just 1. The same outermost electron configuration. The same outermost electron configuration. Hydrogen has just one electron in the outermost shell. Lithium has one electron. The first one is two. Then the last one is the last electron. So it has one electron in the outermost shell, like hydrogen. That's good. Beryllium has two. So beryllium is wrong because beryllium has two electrons in the outermost shell. So beryllium has spoiled the whole thing. Let's go to 3. Hydrogen, the first shell has only one electron. That is, it has only one shell and it has only one electron, and we call it the outermost shell. That's right. Lithium has one electron. It has the first 2 electrons. Then the last one is in the outermost shell, which is just one. Lithium is good. Sodium, it has 11 electrons, and the first 2 is in the first shell. The next shell, it has 8, making a total of 10, and the last shell has only 1. So hydrogen, lithium, and sodium, they have the same outermost electron configuration. So our answer is C. 6 is C. 6 is C. Now let's go to question number 7. What is the relative atomic mass of hydrogen? Relative atomic mass of hydrogen, which contains 99.30% of hydrogen. This is the first isotope of hydrogen, which is 1,1, and 0.70% 2,1. So in order to calculate the relative atomic mass for hydrogen, there is a procedure to calculate relative atomic mass of hydrogen, and this is how we calculate it. For relative atomic masses, to calculate the relative atomic mass of an element, relative atomic mass is equal to summation. That is this sign. This sign here is summation. Summation of relative abundance times isotopic masses. Summation of relative abundance times the isotopic masses divided by summation of the relative abundances. For instance, the abundances are in percentages. The abundances are in percentages. We have for sodium 1, for hydrogen 1, because there's hydrogen 1 and there's hydrogen 2. For hydrogen 1, the relative abundance here is 99.30, and it has a mass of 1. Then for hydrogen 2, the relative abundance is 0.7, and the relative atomic mass is 2. So what we'll do is the relative abundance times the isotopic mass. So the first one is for the first hydrogen. The first hydrogen has a mass of 1 times its relative abundance, plus the second hydrogen, which has a mass of 2 times its relative abundance, divided by the total sum of the relative abundances. The relative abundances was what? 99.30 plus 0.70. So when we do this calculation, we add up everything, will be 100.7 divided by 100. And when we have that, the relative atomic mass would be, the relative atomic mass for hydrogen will be 1.007. Let's see if we have an answer like that. An answer like that will be, a possible answer like that will be, a 1.01 is 1.007 is like a 1.01. So 1.01 is like 1.007. So the possible answer here is, for our calculation, is A. So, 8. Which of the following periodic properties decrease down the group? Periodic properties will decrease down the group. Now, atomic radius. Atomic radius is not decreasing down. Atomic radius, instead, it is increasing down the group because the number of shells are increasing. B. Electron affinity. Electron affinity is not the one. C. Electronegativity. Electronegativity is decreasing down the group. Electronegativity is decreasing down the group. Then D, ionic radius. Ionic radius is also increasing down the group. So the only possible answer for this is C. Electronegativity is decreasing down the group. So our answer for 8 is C. Now let's go to question number 9. One of the main characteristic property of transition metal is their ability to characteristic property of transition metal. Remember that transition metals, they are found within the D block. Not all the not all the D block elements are transition metals. So therefore, transition metals have some unique characteristics that are special only to them. For instance, formation of colored compound, variable oxidation states, they are very hard. They can, the catalytic property, they are used as catalysts in reaction. There are a lot of them. So let's see, as the question implies, one of the main characteristic property of transition metal is their ability to what? Ionize readily by electron loss. It is not possible. That is not appropriate. B, form basic oxides. It is not appropriate. C, react with water. Not appropriate. Exhibit variable oxidation state. That is one of it, which I also mentioned that these are unique among the transition metals. So our answer for 9 is D. Question number 10. Question number 10 has to do with the melting point. Question number 10 has to do with the melting point. It has to do with the melting point. So now, question number 10. The question reads, the high melting point. The high melting point of ionic compounds are due to, remember, high melting point of ionic compounds. It should come to your brain that ionic compounds, these are compounds that are held by strong electrostatic force of attraction. The force of attraction between the ions, oppositely charged ions that attract, the force of attraction between the oppositely charged ions, the positive and the negative. That force of attraction is electrostatic force of attraction. And because of it, it gives rise to a high boiling point. It will need high energy to overcome that force of attraction. So let's go to our question. The high melting point of ionic compounds are due to the presence of electrostatic forces of attraction. I just mentioned it. B, their ability to dissolve in water will not determine their high melting point. Ability to exist as solids, that does not determine their boiling point. D, their ability to conduct electricity, that does not determine their boiling point. So what determines their boiling point is the force of attraction. That force that is holding the oppositely charged ions together. And because of that force, high energy is needed to overcome it. And that force is what? Electrostatic forces of attraction. So our answer for 10 is A. Answer for 10 is A. Now, let's go to question number 11. Which of the following molecule has the strongest covalent bond? Covalent bond. Now, our covalent bond here, the covalent bond, remember what for the purpose of revision, dear learners, covalent bond, what will determine the strength of the covalent bond will be the strength of the covalent bond, the number of bonds that are there. Remember that double bonds are stronger than single bonds. Triple bonds are stronger than double bonds. So, which of the following has the strongest covalent bond? Hydrogen molecule, chlorine molecule, oxygen molecule, and nitrogen molecule. All these, they have hydrogen is one, has just one single bond. Chlorine just single bond. Oxygen has a double bond. It would have been oxygen, but nitrogen has triple bond. Nitrogen molecule has nitrogen triple bond nitrogen. So nitrogen will have, because nitrogen has, and between the two nitrogen atoms there is a triple bond there. Nitrogen is the strongest covalent bond. So our answer for 11 is D. Now, which of the following molecule is non-linear? The linear nature of the molecules. If you have after covalent bonding, using your knowledge of bonding to draw the structure of molecules, you will know that which molecule is linear and which one has a trigonal shape and which one is tetrahedral. From here, which of the following molecule is non-linear? Non-linear. Okay. If you look at this, carbon dioxide is linear, yes. A fluorine molecule, it is a fluorine molecule. We cannot say it is non-linear. A water molecule, hydrogen chloride molecule, we cannot say it's non-linear. The only one that is linear is non-linear is water molecule. Why do I say it is water molecule? It is water molecule because if you look at the molecule of water, this is water. Water is like this. It's H2. That is H2O. Water is like this. Water is like this. It has the oxygen molecule. The oxygen atom has 2 electrons on it. But because the lone pair of electrons here, there's repulsion. The repulsion here, that is the repulsion between the lone pair of electron and the bonded pair of electron is high. What happens? There is going to be the lone pair, there's going to be repulsion here. This one is going to repel this. The repulsion between the bonding pair of electron and the lone pair of electron. There's going to be repulsion here like this. It's going to repel the bonding pair. And this is going to result in what? It's going to result in oxygen in the water molecule having this structure. And that is why at times they will refer it to the water molecule having a V shape. V-shaped. By referring it that water molecule has a V shape because of the repulsion between the bonded and lone pair of electron. So for that purpose, water is non-linear. It has but a V shape. Okay, so for that purpose, we are going to take water to be non-linear. This one is linear, this one is linear, this one is linear, but this one is non-linear because of repulsion from the lone pair of repulsion between the lone pair of electron and the bonding pair of electron, which I've just shown there. So our answer for 12 is C. Now we go to question number 13, which is naphthalene. Naphthalene crystals are held together by naphthalene crystals. This is the structure of naphthalene. Naphthalene crystals, these are white crystalline solid. These are white crystalline solids. This is the structure of naphthalene. They are white crystalline solids. An example of the naphthalene that we use in our common day is camphor. Camphor that some people may take it and even put it among their clothes to deter maybe insects or something like that. It's camphor. Okay, now this is naphthalene. This is naphthalene. The question says, after knowing the structure of naphthalene, this is what the question says. Naphthalene crystals are held together by hydrogen bonds. They are held together by nitrogen bonds. They are held together by van der Waals forces. They are held together by dispersion forces. They are held together by electrovalent bonds. It is not hydrogen bonds. We cannot say it is hydrogen bonds. We can't say it is dispersion forces. What we say, the right word would have been London dispersion forces. And London dispersion forces, these are forces, or what we call the induced dipole attraction. No. Electrovalent bonds? No. The right word to use for such a molecule, because the crystals here are held together by van der Waals forces. They are the van der Waals forces that hold these together. The van der Waals forces. So now, our answer for this is B. Question number 14. A metal Z forms two chlorides, ZCl2 and ZCl3. What type of bond exists between Z and chlorine? The type of bond that is existing between a metal Z and chlorine. If it can form ZCl2 and ZCl3, what type of bond is existing between these? Now we can say, is it a covalent bond? Because this bond is like ZCl2 is like an ionic bond. They say a metal forms two chlorides. A metal and chlorine is what? Chlorine is a non-metal. A metal and a non-metal, what type of bond exists between a metal and a non-metal? It is not a covalent bond. It is not a dative covalent bond. It is not a metallic bond. The only bond that exists between a metal and a chlorine atom, say between two chlorides, a metal and a chloride, what exists between them is an ionic bond, or what you call electrovalent bond. So our answer for 14 is C. Metal and non-metal bond. Okay. 15. Which of the following bonds are broken when ethanol boils? When ethanol, which of the following bonds are broken when ethanol boils? Remember that ethanol is a molecule. Look at it. Okay. Between ethanol, this is the molecule of ethanol, CH3CH2OH. Oxygen, as I said, has two lone pairs of electrons up and down. Now, what is happening here is this. These are all ethanol molecules. And now the bonds between the ethanol molecule is what? This is a hydrogen. Hydrogen is attached when hydrogen, which is attached to a highly electronegative element, which is oxygen, is bonded to the lone pair of electron of another electronegative element. We call that type of bond a hydrogen bond. A hydrogen bond is a bond formed when hydrogen that is attached to a highly electronegative element attaches itself to a lone pair of electrons. So this is what is happening here. This hydrogen hydrogen which is attached to an electronegative element highly electronegative elements such as oxygen, now forming a bond here with a lone pair of electrons of another electronegative uh, uh, element, which is the same oxygen. So that bond between hydrogen and the oxygen is what we call, is not a covalent bond, is what we call the hydrogen bond. So it should be noted that between the molecules of ethanol, there are hydrogen bonds in between. They are the hydrogen bonds that are holding the molecules of ethanol together. So to boil, it will require a high amount of energy to overcome this bond. So let's go back to our question. The question says, which of the following bonds are broken when ethanol boils? Is it hydrogen bonds? Is it ionic bond? Is it covalent bond? So A, one only. Our answer is what? Our answer is A, because we talked of hydrogen bonds. So question number 15 is A. Only hydrogen bonds are there. So now let's go to question number 16. Which of the following equations represent a reaction that is not feasible? A reaction that is not feasible. A reaction that does not take place. Okay. Now, chlorine plus sodium bromide. Of course, the reaction will occur. Chlorine is going to displace, chlorine is more reactive than bromine, so it will displace bromine. Chlorine plus potassium iodide. Of course, chlorine is more reactive than iodine, so it's going to displace the iodine and form potassium chloride, and iodine will be displaced. Chlorine plus sodium fluoride. It's not going to be possible here. Fluorine is more reactive than chlorine. Fluorine is higher up in the in the periodic table, in the group of halogens. Fluorine is higher up than chlorine. Fluorine is more reactive than chlorine. For that purpose, chlorine cannot displace fluorine, and this reaction cannot work because this one is less reactive and fluorine is more reactive. So this one, chlorine, cannot displace fluorine. D, chlorine plus potassium bromide. Of course, chlorine will displace bromine because chlorine is more reactive than bromine to form potassium chloride and this other one. For that purpose, the only reaction that is not feasible is C. For 16 is C. Okay, 17. 1 mole of a compound MOH, that is a metal hydroxide. This is a metal hydroxide. 1 mole of a compound MOH2, this is a metal hydroxide, has a mass of 58 grams. What is the relative atomic mass of M? Now we have been given hydrogen equals to 1 and the relative atomic mass of oxygen equals to 16. To solve this problem for the metal hydroxide, the MRO, or what we call the relative molecular mass of MRO, is equals to 58. Okay, let's add it up. The metal plus, there are 2 oxygen. Oxygen is 16. 16 times 2 is 32. Plus hydrogen is 1. 1 times 2 is 2, giving the total of 58. So, the total of 58. Now, M plus this equals to 58. To have the value of M, it will be 58 minus 32 plus 2. That is 58 minus 58 gram minus 34 gram. And the value of M will be 24. That metal will be 24. And if we look on the periodic table, the metal that has 24, the metal that has the number 24, the mass which is 24, That metal should be, let me just check briefly on the periodic table. The metal will be 24. The metal is the metal will be magnesium. The metal will be magnesium. So 24 will be magnesium. So now M is 24. Let's go to our answer column. What is 24 here? 24 for 17. 24 is A. 17 is A. Now let's go to question number 18. Question number 18. Nitrogen combines with oxygen to form two different oxides, in which 1 gram of nitrogen combines with 1.12 gram of oxygen and 1.714 gram of oxygen respectively. Yes. Now, these observations illustrate the law of A. These observation illustrate the law of A. Constant composition. B. Conservation of mass. And C. Chemical combination. And D. Multiple proportion. Remember that it is also it should be recalled that the mass is neither created nor destroyed, but can be transformed. It can be transformed to another form of equal mass. So in this case, if you look at this critically, the answer for this is the mass or the conservation of mass, which is B. Number 19, if 60 cm cube of a gas is heated from if 60 cm cube of a gas is heated from 27 degrees Celsius to 77 degrees Celsius, that is, the initial temperature is 27, the final temperature is 77. What is the new volume of the gas at constant pressure? Constant pressure. Okay, there are different gases, law of gases. We can have Charles' law, Boyle's law, different gas laws. There are different gas laws. Now, what is Charles' law? Charles' law states that the volume of a fixed mass of gas is directly proportional to its absolute temperature, provided the pressure remains constant. We have been told at constant pressure. We have been told at constant pressure. So what we are going to apply here is Charles' equation, gas equation. So volume is directly proportional. Volume is directly proportional to its temperature. That is, as the volume increases, the temperature also increases. So V is equals to KT. So if we write this equally, we will have V initial volume divided by initial temperature, which is equals to final volume divided by final temperature. And since we have been asked to look for what? Okay, what is the new volume of the gas at constant pressure? So our final volume will be V2. We are going to make V2 the subject. And making V2 the subject of this equation, we will cross multiply and divide all by T1. So V2 will be equal to V1 times T2 divided by T1. And taking our data carefully, the initial volume was 60 cm cube. We are looking for V2, which is the final volume. The initial temperature was 27 degrees Celsius. We must make it to be Kelvin by adding 273, which will be 300 Kelvin. Now, the final temperature was 77. We must add 273 there, making a total of 350 Kelvin. And when we have this, we substitute these values here. V2 will be 60 cm cube times 350 Kelvin divided by 300 Kelvin. Our final volume would be 70 cm cube. And if we come here to our answer column and we look at it where we can have 70 cm cube, our answer for 19, our answer for 19 will be C. Now, question number 20. Question number 20. The pressure of a gas is due to what? The pressure of a gas is due to absence of attractive forces between molecules. No. The pressure of a gas is due to the constant random motion of molecules. Is not feasible. The pressure of a gas is due to collision between the molecules and the walls of the container. Of course, when let me say in a chemical reaction, let me say a gaseous chemical reaction, and we say we increase the temperature. When we increase the temperature or the temperature of the reaction, you will see that the particles will acquire kinetic energy. This energy they are going to acquire like that will acquire kinetic energy, or will acquire energy that is which is equal to or above the activation energy, and that is going to make the particles, more of the particles, to collide among themselves and among themselves and on the walls of the container, thereby increasing the pressure. So when there is collision between the particles and on the walls of the container, the pressure increases. So collision between the molecules and the walls of the container is what determines the pressure of a gas. Our answer for 20 is C. Question number 21. Question number 21. Liquids with strong intermolecular forces have small number of molecules escaping into gaseous states. Low boiling points, large number of molecules escaping into gaseous states, high vapor pressure. It's not the high vapor pressure liquid with strong have strong intermolecular forces. High vapor pressure, no. Large number of molecules escaping into gaseous state. If there are a large number, what makes them to escape into gaseous state is because the forces of attraction between the intermolecular forces between the molecules are weak. A low boiling point, that's not the case. Small number of, when there are strong intermolecular forces holding the molecules together, only a small number of molecules will escape into the gaseous state. Question, answer A is right. 21 is A. 22. The collision between the gas molecule is perfectly elastic because it is perfectly elastic because the cohesive forces between the molecules are negligible. There is no loss of energy during collision. They are highly compressible. They move randomly in straight lines. So you will see that with this, you will see that there is no loss of energy during collision. There is no loss of energy during collision. Question number 23. The similarity between combustion and the neutralization reaction is that similarity, combustion and neutralization, is that there are question 23, that they are endothermic. Not appropriate. Because in a combustion reaction, what happens when something is burnt in oxygen? That is what we call when something is burnt in oxygen, heat is released. Within that, heat is released to the environment. That is why you will always feel heat within the environment that there is combustion taking place. So any combustion reaction is exothermic. The neutralization reaction, when let me say an acid-base reaction or an acid-base reaction, you are putting an acid into a base in the laboratory holding that test tube. You will realize that the test tube that you are adding the base into it, or you are adding the acid into the base, that test tube generates heat. The test tube is hot, indicating that heat has been released, indicating that it is an exothermic reaction. So the only similarity between them, I can say the reaction, they are exothermic. It's not oxidation, it's not reduction. They are exothermic. So 23 is exothermic, which is B. 23 is exothermic, which is B. Then, question number 24. When an ionic solid dissolves in water, when an ionic solid dissolves in water, the water molecules split the crystals into free ions. When an ionic solid dissolves in water, the water molecules split the crystals into free ions. The energy required for this process is what? Is it kinetic energy? Is it kinetic energy? No, it's not kinetic energy. Kinetic energy for locomotion, movement. Is it potential energy? No. Is it hydration energy? No. Hydration energy. It is similar to hydration energy. Is it lattice energy? No. The only possible answer here is hydration energy. But remember, energy released, for purpose of revision, energy released or absorbed, the enthalpy change. Let me give you something. For revision purpose, the enthalpy of solution. Enthalpy of solution is the energy absorbed or released when 1 mole of an ionic solid dissolves in water to form a dilute solution under standard condition. That dilute solution is always with free ions. When 1 mole of an ionic solid dissolves in water to form a dilute solution under standard condition. For example, this is sodium chloride, which is an ionic solid. If it dissolves in water that is aqueous, it will give us sodium ion plus the chloride ion. These are free ions. What I expected should have been enthalpy or energy of solution. What I expected, the most appropriate answer there would have been a solution would have been energy of solution or enthalpy of solution. But since it doesn't have any link with kinetic energy, potential energy, or lattice energy, we will take C to be the answer here. But the most appropriate answer is enthalpy of solution for this definition given here. C is the only appropriate one for this definition. Question number 25. The reaction of ammonia. The reaction of ammonia with excess air in the presence of heated platinum catalyst would yield a reaction of ammonia with excess air. Ammonia with excess air in the presence of heated platinum would yield A. It will yield water and nitrogen 2 oxide. It will yield water and nitrogen 4 oxide. It will yield water, vapor, and nitrogen. It will yield water vapor, and ammonium ion. The appropriate answer for this reaction, that is ammonia with excess air, will be water, nitrogen for nitrogen 2 oxide. Nitrogen 2 oxide, that is nitrogen monoxide. Nitrogen monoxide. So number 25, A is the right answer for this. Water, nitrogen monoxide. Number 26. Which of the following chemical equation illustrate behavior of an acid? Behavior of an acid. What is an acid? An acid is a proton donor. A base is a proton acceptor. Let's see if it is applicable here. Okay, we have X2O. X2O plus H2O. Okay. Does it show a sign of, is there any sign of, we are not, instead, X has lost this and everything is here. D1 does not behave as an acid. Which of the following chemical equation behavior of an, which of the following chemical equation illustrate behavior of an acid? No. B, let's take this to be hydrochloric acid. Hydrochloric acid in water. Let's say this is dilute hydrochloric acid in water. Dilute hydrochloric acid in water. I said an acid is a proton donor. If an acid now donates, if this hydrochloric acid, let's say it is hydrochloric acid, it donates its proton. If it donates its proton, the proton, since oxygen here, this one is going to behave as a base because there are two lone pair of electrons here. The proton will attach itself to the lone pair of electron here. In that case, we say a base is a proton acceptor. Meanwhile, an acid is a proton donor. So HX, X is going to donate its proton, which will come here, and this one is going to accept a proton. And the resultant will be this one and this one. So the only equation that is going to behave, which of the illustrate behavior of an acid? So this one that is going to behave here will be this one. Is only B. Then HX, XL is not donating any proton. Even if it donates a proton, nothing is happening here. X here, what is not? So the only thing that is behaving like a proton here is this. This as an acid, illustrate behavior of an acid. HS is going to donate a proton. This proton is going to be accepted by this molecule of water, by this by water here to form hydrozonium ion, H3O plus, and the X will now be released. So it is B that is going to be behaving as this an acid-base reaction. So it's B. Let's go to question number 27. Which of the following acid is a weak acid? Question number 27. Which of the following is a weak acid? Okay, from your weak acid, remember, fellow learners, that a strong acid will dissociate completely. Weak acid will not dissociate completely. They will partially dissociate, or they will partially ionize. So all acids, especially inorganic acid, are strong acid because they dissociate or they ionize completely. But weak inorganic acids, they ionize or they dissociate partially. For example, let's say which one of the is a weak acid here. When this one dissociates, it gives out all its protons, so it dissociates completely, or it ionizes completely. It is H plus NO3 minus. So this one too, same. When this one ionizes in solution, it's going to give all its proton. So it will be it will be 2H plus SO4 2 minus. When this one ionizes completely, it is going to do that. This one too, it will not, this one will only, when this one ionizes in solution, in water, is going to give 2H plus HPO4 minus. There's still going to be an HPO4 minus in this one. So this one is not, this one does not ionize completely. It doesn't ionize completely. So that is the situation. So for that reason, or in other words, if you cannot dictate it like that, that it can ionize like that, this one A is the one that will not ionize completely, or will not dissociate completely, or will undergo partial dissociation or partial ionization. So now, so what is going to happen here? Or you can say, among all these elements here, we have nitrogen. In between, we have sulfur and we have chlorine. All of them are all strong they have strong electronegativity. So because phosphorus that is here, phosphorus that is in H3PO4 is the least electronegative, because this one is very, nitrogen is a very strong electronegative, chlorine is a very strong electronegative, sulfur is also strong, but phosphorus is the least electronegative and will pull electron very weakly. Least electronegative, it will pull electron very weakly, hence resulting in incomplete dissociation. That is why it will dissociate and it will only have 2H plus minus plus HPO4 minus. So the only weak acid here is A, which is H3PO4. That is 27. Now 28. 28 is when an alkali is warmed with ammonium trioxonitrate, that is ammonium nitrate. When an alkali is warmed with ammonium nitrate, the gas liberated is it nitrogen monoxide or nitrogen 2 oxide? Is it nitrogen dioxide? Is it dinitrogen oxide? Or is it ammonia? When an alkali is warmed with ammonium trioxonitrate, the gas that is liberated, if you do this in the lab, you will realize that, and using a litmus paper, you will realize that the gas will turn the red litmus paper blue. And if the gas that is being produced here turns the red litmus paper blue, it shows that it is an alkaline gas. It is an alkaline gas. And the only gas that is that one, a weak alkaline gas, which is ammonia. So the gas that is released here is ammonia. Number 29. Which of the following compounds will not dissociate completely in water? Is it hydrogen carbonate? Hydrogen carbonate? Is it sulfuric acid? Is it nitric acid? Or is it sulfuric acid? Of course, you should know that the one that will not dissociate completely, as we just discussed, you know that hydrochloric acid is a strong acid, it will dissociate completely. Nitric acid is a strong acid, it dissociates completely. Sulfuric acid is a strong acid, it dissociates completely. The only weak acid is this one. This acid will dissociate. This acid will dissociate. The weak acid is this one. It will ionize or it will dissociate partially to give, when this one dissociates, it's going to give something like this. It's going to give something like this. When this one dissociates, it's going to give something like, that is H2, CO3. When it dissociates, it's going to give something like yeah. It's going to use something like this plus H CO3 minus. It's going to give when it dissociates, it's going to give something like this. It's going to give one hydrogen ion plus HCO3 minus. This is a bicarbonate. This is a bicarbonate. Which is a bicarbonate, a bicarbonate ion. So this is a bicarbonate ion. So when H2 CO3 dissociate, it's going to give a hydrogen ion and a bicarbonate. That is HCO3 minus. So in that case, the only one which the question says which of the following compound would not dissociate completely. B, C, and D would dissociate completely. They are all strong acids. This one will not dissociate completely. Instead, it will dissociate, giving only one proton or one hydrogen ion and a bicarbonate ion. In that case, we say our answer is A. A is the one that is 29. A is this one that will not dissociate completely. And in that case, that is the one that will not dissociate completely. Question number 30. Consider the process represented by the following chemical equation. Sodium chloride solid dissolve in water to produce sodium ion, chloride ion, and more, some of the solid is of the sodium chloride is still there. That is a solid, which is this sodium chloride salt, dissolve in a solvent. It happens that all the solid does not dissolve. Part of it dissolves and some is still left. In that case, this is like a saturated solution. Note that such a solution is a saturated, such a solution in a solution where not all the solid is dissolved in the solvent. Such a solution is a saturated solution. When all the solid is not dissolved in the solvent, then at the end of the day, we still have we have ions, and some of the solid salt left, we now say the solution is saturated. So, what is our question? What does our question wants? So the equation represent a saturated solution. The equation represent unsaturated solution. The equation represent solid dissolved in a solvent. A solid dissolved in a solvent. The equation, yes, it is solid dissolved in a solvent, but it does not give, it's not explaining everything. Okay, and fully dissociated solvent. Here, a simple term to describe this type of reaction. I say when a solid is dissolved in a solvent, and at the end of the day, we have a solution where there are some ions, and some of the solid is still left undissolved. We call that type of solution a saturated solution. That is a solution that can no more take more solid. When the solvent can no longer take a more solid, the solution is saturated. So in that case, answer A is our right answer. Well, thank you very much for watching. We will be starting to complete the rest of the questions for part A. So thank you for taking your time to listen to the questions and have the explanations. Once more, if you haven't subscribed to our channel, please like this video, subscribe to our channel so that the rest of the other papers that we are going to be discussing, you will be having them. Thank you very much.